Welcome to my new series that I'm making, which is going to be a series called GameDev Building Blocks. And basically, what the goal of this series is to take really simple, kind of basic ideas that are essentially almost engine agnostic, meaning like these are kind of building blocks that you're going to find not just in Godot, which I'll be using to teach in, um, but also really any game engine or even programming just in general. These are concepts that can be pretty useful. And the goal of this series is to kind of have a consistent format where we kind of go through three phases. The first phase is we introduce the concept and we kind of talk about it a little bit. Number two, we will talk about maybe some concrete examples where this concept could be applied in game development. And then the third phase, which I'm really excited to show everyone, is I'll actually be using examples from some of my projects that I've been working on, as well as if I can't find a good example in one of my projects, then I may use one of the official Godot example projects. Or the other thing I was thinking that might be kind of cool is I downloaded the Doom source code. That's it's been available for a while. Kind of John Carmack at id Software. Those of you who know, the legendary game dev studio behind Wolfenstein and Doom and Quake. Those games have the source code has been released and it's perfectly legal. You can download the source code and it's actually a great way to learn. I've been poking around through that code and even though it was written a long time ago, it's just those games are kind of famous for being very well designed and written and things like that. So we may see examples from that at some point too. But today is going to be an example from one of my own games that I'm working on. The topic of today is going to be const versus var. If you'd like to follow along with me, um, I build really simple examples. Like if I'm basically going to try something really simple, what I'll tend to do is I just have a brand new version. I'm just working in Godot 4.1 here, and then I'll just start a new scene with this other node here, and then I will just type in node, okay? Just your basic plain old node, right? And then I'll usually call it the name of my example, which in this case is const versus var. I just want to show some things, okay? And then what I'll do is I'll just save this scene. So I'll go up to here, your scene manager here, and I'll right click, save scene as, and I'm just gonna put it in a folder so that I have it, okay? Um, and then once I do that, I'll attach a script, and it's gonna inherit node. It's just gonna be empty, okay? And we'll call it const versus var.gd, and this is going to be kind of the main setup for most of my simple examples. So if you want to follow along, you know, uh, that's all you have to do. Now, let's say you're trying to write code like in C, for example. Well, a lot of times, like you'll put let's say you're trying to learn, you'll put the thing you're trying to learn in the main function because that gets run. You compile your code and with things like CMake and things like that, you get an executable, and then you run that to test your code, right? Well, when you're working in a game engine, sometimes it can be a little hard. I know for me, it was confusing at first to how do I test code? Like how do I want to just kind of like test simple examples. And so what I would say kind of my go-to method is a really simple setup where I'm basically using the ready callback of the engine in order to do some testing, okay? So the reason this works is because the ready callback is a method that fires whenever the node that this script is attached to readies up, okay? So if I just run my scene here, by the way, this button right here will run current scene, but the shortcut for that is F6, okay? So if I run this current scene here, basically what's happening remotely is that this node here, our scene, with this single node, it's basically entering the tree, readying up, and then it'll call this block of code. So that's a good place to kind of put some test code. So for example, I could do print hello world, the classic example, right? And then I could do this, and then I get my hello world. So you'll see me kind of do this basic example for testing for testing things a lot, okay? So I think sometimes it can be a little confusing because maybe, if you're brand new, you might go, wait a minute, what's like func, underscore ready, arrow void, that could be a little bit confusing. But just to simplify it, this is basically a callback, which if you don't know what a callback is a method that is scheduled to run at a time later. It comes from the phrase, I'll call you back later, right? So this method will be run when the ready callback is scheduled to fire. And when is that scheduled to fire? When the node readies up in the scene. Okay? So I hope that makes sense. Let me know if you have any questions on that. So that's kind of the basic testing setup. I'm not going to go through all that with every video in this series, but for the very first one, I will go ahead and go through that with some detail. So now let's talk about var and const. So these are some keywords in GDScript and in most programming languages that allow you to create variables, right? And the interesting thing is that both var and const technically create variables, which might be kind of confusing. So if I do, let's say, const, and let's say I'm making like an RPG, so I'll do like max health, and let's keep things simple. Let's set it equal to 10, okay? And then I'll do var, and then I'll do max mana, and we'll set that equal to 12, okay? Just to have some examples, okay? So what's the difference between these things? Well, as I said, a variable at a fundamental level is kind of like a container for some information, right? It holds some type of data for you. So that could be like a number or maybe a string, right? There's lots of things, but at the end of the day, you'll find that when you start to develop your own games, you'll find that a lot of times you're just kind of like, you have all these containers for, these this data that's flying around your game. So maybe like the number of hit points of an enemy, or maybe, an attack that does a certain amount of damage, or maybe you have a certain amount of, gold to spend or something, right? Like these things are like so fundamental to the idea of games that it's really important to kind of understand them and feel comfortable with them. So both of these create variables, but the difference is that const makes it so that once this variable has been assigned a value of 10, it can't change, okay? Whereas if you declare a variable with var, that means that this variable is allowed to change. So I'll show you that. So let's do this. Let's print max mana, okay? And how about we'll do this? We'll do my max mana is, and then we'll just do concatenate, and then we'll just wrap this in str, which basically what that does, I can show you what happens if I don't have that. I should explain this a little better. So I'm basically doing a print statement, which takes a string, okay, but then I also want to print out max mana. Now, watch what happens if I just do like max mana, right? So I just type the name of the variable in the string. Those of you who might be more experienced, you might know what's going to happen. But if I run this, you see how it says my max mana is max mana? The game, even though I know this is the name of a variable, what Godot thinks is like, that thinks that I literally want to print out the name max mana, right? So what we'll do is we'll stop the double quotes here, and then we'll add a plus sign. And what this plus sign says is it says I want to do what's called concatenation, which is where you can combine strings together, okay? But I'm still going to have a problem if I do this, okay? If I do this and then I run, you see, it said invalid operands, string and int. So you can kind of reason this out if you think about it. Like max mana is an integer, and this part is a string. So Godot is saying, hey, I'm sorry, I don't really know how to add numbers to strings, you know? And it makes sense. Like that would be kind of confusing, right? Well, luckily we have some built-in methods that are really useful for a situation like this. There's a method that's accessed by typing in str, okay? And what that does is that takes an argument and it will spit out a string. So now what this method allows me to do is it takes this variable, which was an integer, okay, and it turns it into a string. So now instead of string plus integer, because of this helper function, I now have string plus string, right? So now if we run this, we should see, let's see here, my max mana is 12, okay? So that's how you can print out the value of some variables. By the way, if you're not concatenating, you don't need to do like this, you know? You could just print it out normally. But I wanted to have some extra context for you by having the debug there. So I'll just show you that. So see, it was able to print 12. So if it's just a variable by itself, you can usually just print it, you know? So now watch what we're going to do. We're going to say, hey, maybe we leveled up, right? So maybe max mana, let's give us, 5 more mana, right? And then let's see what happens. So my max mana after level up is, and then we'll do our concatenation, we'll do our str helper function, and we'll pass in max mana again, okay? So let's see what happens. You can kind of, pause the video if you want and like, try to predict what's going to happen. But let's see. Okay, so my max mana is 12 and my max mana after level up is 17. All right, cool. That seems useful. We have a variable called max mana and we can change it, which makes sense because in the game, ostensibly, you would be able to increase the maximum amount of mana, right? Well, let's try to do the same thing with max health, right? So let's start out. We'll just print out max health. Okay, so I'm going to comment out these lines here. So we'll just print out max health. So we'll say my max health is, okay. Now remember, we declared this one with a const, right? So, okay, my max health is 10. No big deal. All right, let's try to increase that. So we'll do max health. Let's give us 8 extra health points, right? And then so we'll say my max health after level up is str and max health here. Okay. Now notice that the editor is actually not going to let me do this. It says cannot assign a new value to a constant. So this kind of proves my point where once a variable that has been declared as a constant is given a value, you can't change it. Okay. Now when I first learned this, I kind of had a, I guess, negative reaction to that. I kind of thought like, well, what good are consts? Like, if it feels like a restriction, right? Like, I think generally speaking, as humans, we're a little bit conditioned to kind of not like restrictions, right? It's like, hey, don't tell me what to do. Like, if I want to change it, I'm going to change it. That was kind of my reaction. But the more I got into game development and the more my projects got bigger and bigger, I learned to really actually love const. And what at first seems like a huge limitation, like you can't change the value, once your projects get to a certain amount of scope, you're actually really, really grateful for the ability to not to have something constant, okay? Because what ends up happening is invariably your game grows to the point where there's a lot of things going on, a lot of systems, a lot of data is passed around, right? And one of the most frustrating things that can happen is you may be working on your game and all of a sudden there's some unexpected behavior going on. Like something really odd is happening. Like maybe, for example, there's some kind of bug where, the boss you think the boss of the level is supposed to have 1,000 health, but sometimes they have 1,000 health and sometimes they have 8,000, and you're just trying to figure out like why is that happening? Like where is it changing? And this is where the concept of a const can really come to the rescue because you know, when you're trying to track down, like, gosh, like I expect this variable to be this thing and it's not, you're running around your code trying to figure out, where the problem is, like, where is this thing changing? Well, you'll never have to do that with a const, right? A const can never change. So you'll never have a hair pulling out moment with a const changing to something and you don't know why it's changing, right? So um, what I would say is that when I first learned about consts, my general reaction was negative. I was like, oh, I don't really want to use those. Like, I'm just going to make everything a variable, right? But then I started to change my thinking and I said, well, sometimes I'll use consts. Those seem like pretty useful, but my default's still going to be variable, right? I'm always going to start with things being variables. And if I can think of a good reason, then I'll make it a const, right? And since then, I've kind of progressed in my thinking even further. And now, what I think of is my default is I want to make it a const, right? Because what you'll find is the less things that can change in your game, the less things that can go wrong, right? Now, of course, in any kind of game, stuff has to change. Like that's kind of fundamental, right? Is like, there's lots of parts of your game that have to change, but to the extent that there are parts of your game that don't need to change at runtime, then you might want to consider using a const, right? And the other thing here is I want to make a distinction between can't change versus can't change at runtime, right? So when we say const, I think it's very important to understand we mean you cannot change that variable at runtime. It doesn't mean like you're locked in, right? Like, and I know this might seem obvious to some, but for me, it was like a little bit like I used to think this. I used to be like, oh, I don't want to make max health a const because maybe I want the boss to have 100 health, right? Like I haven't, figured out the balance of my game. Maybe I want the boss to have 1,000 health, right? But the thing is, like, yeah, even if you make the const uh, 10 now, there's a difference between something needing to change at runtime versus something needing to change at all. Like, there's absolutely nothing stopping me from, testing the boss, realizing, oh, you know what? The player needs a bigger challenge. Let's change that max health to 100, right? That's okay, right? We can change that. There's nothing wrong with that. But the point is that this variable is not going to change out from under me during runtime, right? While your game is running. That's a really important thing to think about, okay? So I hope that explains a little bit the power of const, and I hope that you will find a way to use it in your projects. Again, it's kind of, almost all the lessons that I'm going to be sharing in this series are things that I didn't know until I started working on projects that had grown to a significant enough scope to where you go, oh, that's why people always told me to do this, or that's why this is a feature, It's almost like I had to kind of learn by stubbing my toe, right? And so part of this series is to try to kind of pass on some of that knowledge. Now, some of it, you're just going to have to learn just by doing, right? But to the extent that I can kind of, be like, hey, these were a lot of mistakes that I made and this is what I learned from it. That's kind of mostly what this series is about, okay? So now that we've done a simple example, let's talk about some concrete examples in game development where you may want to use a const. So one of the areas is, let's say your game has a currency, right? So for example, maybe you have this concept of, I think about maybe like a game like World of Warcraft, right, where you have like copper, silver, gold, right? So maybe, you're figuring out your currency system, right? And so, you're starting out and you're like, okay, so a copper is going to be worth, one. Just to keep things simple, we'll do a variable where it's like player copper. let's say they've got like 10 copper, their player silver. Let's say they've got 8 silver, and let's say they have 1 precious gold nugget, right? They saved up, they grinded those mobs, they killed those murlocs, right? So let's say, these are what the player has, right? So, this is like how you set it up. So now you want to calculate like how much money the player has. So we could do var money equals, and then so what we'll do is we'll do player copper times the value of a copper, right? I guess maybe what I should do to make this more clear is I'll call this copper value, silver value, and gold value, right? You know what? We're just going to do it all on one line. I know it's a little ugly, but just for this example, it'll be okay. All right. So that's how we're going to figure out how much money the player has. And so what we'll do is we'll print the player currently has, and remember, we're going to need our concatenation because remember, this is going to be a number, right? So we'll do plus, we'll use our stir helper function, money, and then we'll concatenate onto that another string, okay? So we're saying the player currently has, and then we're converting the money that we calculated into a string, and then we're adding this part on the end, all right? So let's check it out. All right, the player has 1,810 money. That seems reasonable because 1 gold is 1,000, 8 times 100 is 800, and 10 times 1 is 10. That makes sense, okay? So you go on your merry way and you're building your game, but then all of a sudden, a crucial bug leaks into your game, and you're having a really weird situation where sometimes some players, the amount of gold that they're getting for things, the calculations, like they seem to be really off. Like something is going on, right? So you're hunting through your code, and you realize that holy crap, somewhere down the line, my game, and remember, you might not think this would happen, but trust me, once you have a lot of systems going through your game, someone came in and changed copper value to 100, right? Like let's say again, this would happen somewhere else in your code, right? But somewhere down the line, there's maybe a developer that's working on your project that didn't know any better, and they changed it. Maybe they were trying to add 1,000 to their copper or something like that, but because this is a variable, it's mutable, okay? And that's a word that you'll see in computer programming, mutable versus immutable, right? So a const is immutable, you can't change it. A var is mutable, you can change it. So the problem is what happens is if there's a part of your code that's changing the value of copper, well, now all of a sudden, um, that would have to happen before the calculation for it to break. But just to show you here, so if we print out now, we see that the player currently has way too much money, right? Well, okay, so the bug could come from different places, right? It could be that we're accidentally changing the player's copper when we didn't mean to. But the problem is it could also be coming from things like this, right? Where there's no reason for this thing to change, right? So let's make these const, right? So the value of copper, we're going to make const, right? So we'll change those things to const. And now, luckily, GDScript is able to tell me, hey, you know what? Sorry, you're not allowed to change that, right? So this is one less thing that can go wrong in my game, right? It's like I know that at least this is not breaking, right? And that can be like a huge peace of mind. Um, okay. So, and again, like I said, it doesn't mean that, like, let's say, for example, you decide, hey, you know what? I actually want it to be 50 silvers or, silver to be worth 50 of my base currency, and I want gold to be maybe 500, right? Let's say, you do some balancing and that's what you decide. Well, there's nothing stopping me from changing these, right? Just because they're const, like I can actually change them to balance the game, but I know that they won't change at runtime. And I can't think of a good reason why these things should change at runtime. So again, what I'm kind of, teaching here is that, you might want to start thinking about defaulting things to const until you have a good reason for it to be a var. Now, having said that, most of the variables that you create in your game will probably be var, okay? So I don't want you to, go overboard, but it's one of those things where I used to just never use const at all, and now I'm basically constantly, no pun intended, trying to find excuses for using it because I just know that, gosh darn it, that gold value variable, that's a nice safe little value. I'm not gonna have the rug pulled out from under me on that one, okay? So I hope that is a good example and helps explain that. So let's actually talk about where we can use that. So that was a kind of a theoretical game example, but let's actually look at some actual game code, right? So this is a kind of a turn-based RPG game that I've been working on. My development team is a 3-man team. It's me, my identical twin brother, and my youngest brother. So the three of us work on stuff together. And just to show a really simple example, in my game, there's a kind of a phase where you're walking around like an overworld type thing, and then there's a combat phase, right? And so this is the combat arena scene, right? And it's basically a preload to this combat arena.tscene file that's in my folder structure, right? So the thing is, I never want this to change, right? Like, it would actually be really bad if this changed while the game was running. It would mean that for some reason the combat arena scene is no longer attached to the actual combat arena T scene. If this variable were allowed to change, then there could be a bug that could creep up in my code where maybe this gets replaced with a different T scene value. And you might think, oh, I would never do that. You know what? It's like, you'd be surprised. It's peace of mind for me just to know that this thing will never change, right? So I'll go ahead and fire up the game here. And I'll just turn down the volume a bit so that you can hear my voiceover. But this is like basically kind of the overworld. You have your party. There's a treasure chest, so we can get some loot. So this is kind of the overworld part, and then we enter combat, right? And so now here's the combat, right? So the really cool thing is that I know that if we go to my remote tree, we can see here, we can look at the game, and you can see here's the combat arena scene, right? Remember? Here's the path here, combat arena. It came from this scene here, okay? And because it's a const, I can rest assured that at runtime, there's not going to be the rug pulled out from under me like I keep saying, right? Which could break this, right? So I'll do one round of combat just to kind of show you guys the game a little bit. And we'll talk more about this. I have plans to do kind of a devlog series with the game. But I just kind of wanted to show you guys, that, these things that I'm showing you guys are things that I'm actually using in my own projects to try to get stuff done. So I'm kind of powered up right now, so these enemies are relatively weak. Maybe I'll show the switching mechanic. Well, I'll explain more about the game. I don't really want to do that for this video. But let's see. Let's switch out to this guy. So you can see it's turn-based. You could probably figure out which games kind of influence this game just by kind of, looking at it. But we'll go ahead and win this combat. All right, cool. And every time you win a combat, you get your choice of some loot. All right, so we've got some options here. For my little grass mage character, I'm gonna choose this ability and then keep going. So anyway, so that's an example of the concept in play, in an actual project that I'm working on, and I just think it would be kind of cool for folks to see. I think for one thing, it's a little bit hard when you're trying to learn programming and it's all these like academic theoretical examples, right? For me, sometimes that's not the most exciting, right? And so I'm hoping by having a part at the end where we really go into kind of the implementation and how we use that concept to help us build games, it will be interesting to folks, and then it will also kind of prove the usefulness of the concept, right? So anyway, thank you for sticking it out if you stuck around this long. This is the first of several videos that I have planned for this series. Again, this is my Game Dev Basic Building Blocks series, where we just take a simple concept and we just kind of do a little bit of a deep dive on it every time. And eventually we'll have a bunch of tools in our toolbox which we'll use to build games. And these tools are engine agnostic. I know that it could be tempting to really kind of tie yourself to kind of one engine and be really specialized like that. But I do think that one thing that you can do for yourself, especially as an indie dev, right, is be nice and versatile, right? Be nimble, just in case something comes along, right? That a new technology that you want to use, you want to kind of try to train your skills to be transferable, So that's kind of where I'm approaching this learning from. So even if you're not using Godot to develop your games, I think you will be able to learn stuff from this series. Like I said, I'm trying to keep it as engine agnostic as possible. So anyway, take care and see you in the next video. Appreciate you for watching.